Hello and welcome to the content video for 2.1 and 2.2, adding algebraic terms and subtracting algebraic terms from Singapore Math Course 2A. Well, as you can see in this content video, I'll cover both 2.1 and 2.2 together because the process is the same. So let's get started. In these two chapters, you have two subtopics: simplify algebraic expressions with integral coefficients by adding or subtracting if it's 2.2, and simplify algebraic expressions with decimal or fractional coefficients by adding or subtracting. So these are the two things that you need to understand, and once you know these two things, you can solve questions in this topic very easily. So let's get started with the integral coefficients. As you can see, integral is talking about the integers. So for example, 2 plus 3 is 5. So that's what you have to do here. So idea here is the like terms. So if you have 2x plus 3x, the answer is going to be 5x, as you did in the previous one. The same process you follow. So this x here and the x here should not scare you. It's the same addition process that you follow. So if you have 2x minus 3x now, you know how you do. If it was 2 minus 3, how do? You do larger minus smaller. So 3 minus 2, that's 1, and put the sign of the larger number, which is negative. Exactly the same process. The only difference you have here is this x. That's it. Otherwise, you follow the same process. Now, for example, if you have 2x squared plus 3x, what do? Do you write 5x or do you write 5x squared? Well, you write none of this. Okay, because x square and x, they are not like terms. You can add and subtract only like terms. It's very important for you to understand that. Let's say here, instead of plus 2x, we have minus 2x and plus 3x. It's the same process, right? Plus and minus, two different signs. So larger minus smaller. So 3x minus 2x is x, and the sign of the larger, which is positive. And let's say you have both negative, minus 2x and minus 3x. If it was minus 2 and minus 3, you add, right? When both the numbers have same sign, you add them. So that's 5x and put the respective sign. Here it is negative. So this is how you solve it. In the book, they also talk about bar model method, but I'm not covering that because that takes a bit longer. However, you can use that method. That as number gets larger, it becomes difficult. That's good for understanding. But if you understand what I've explained you here, you're good to go. You can solve the questions easily. Let's now look at the other side, the decimal and fractional coefficients. So the process remains the same. Here, instead of integers, you have either decimals or you have fractions. So let's understand with example. Let's say 0.3x plus 0.2x. If it's 0.3 and 0.2 addition, you have 0.5 and you will write the x. So it's the same process. Same thing, if you have minus 0.3x minus 0.2x, it's going to be minus 0.5x, right? Both the numbers have same sign. You add and you put a negative sign. So this is same like the integer. Now let's try some fractions, because when it comes to fractions, it gets a bit tricky if you are not careful. Let's say 1 by 2x plus 1 by 3x. What students usually do is they say this is 2 over 5x, and unfortunately that is wrong. When you have to add or subtract fractions, your denominator has to be same. If they are not same, you cannot add or subtract fractions. So how do we solve this? 1 by 2x plus 1 by 3x. Here, 2 and 3, you find the LCM 6, right? 2 times 3 is 6. They don't have any other factors in common. So it's like 2 equals to 2 times 1 and 3 equals to 3 times 1. So you take the common and uncommon factors and multiply. So that is 6. So your denominator has to be 6. So to get 2 to 6, we need to multiply with 3. And here 3 to 6, we need to multiply with 2. So what's the answer? That's 3 upon 6x plus 2 upon 6x. Now here the denominators are same. So you add them. Now you will add, but you will add only the numerators. Watch out, only the numerators, and the denominator you write as it is. You do not do 6 plus 6 is 12. So this is how fractions are done. Sometimes the fraction, the denominator could be where you can find common factors, and then in that case you can follow a different process. Now here the denominators were small, easy to do. For example, if you have 5 and let's say 10 and 15 as your denominator, how do you find the LCM? You write all these three together, do them together. Let's start with 2 first because we have 10 here. So 2 does not go in 5 in the sense there will be a remainder. So we write 5 as it is. 2 times 5 is 10. And again in 15 we'll have remainder. So we write 15 as it is. Then the next prime number is 3. It will go in 15. So we do with 3. This 2 will remain as it is, and here we will have 5. And then you do with 5, 1, 1, 1. So until you reach 1, 1, 1, you keep doing, and this part you multiply. So it's 2 times 3 times 5, which is 30. So the LCM is 30. So each of this needs to be converted to 30. So you will do this times 6, this one times 3, and this one times 2 to get to 30. So when you do that, remember you multiply both numerator and denominator. You cannot just multiply numerator or just denominator, then you're changing the value of the fraction. When you multiply both numerator and denominator with the same number, you are not changing the value of that fraction. So remember to multiply both numerator and denominator with the same number. So this is how you solve these two chapters. So adding algebraic terms and subtracting algebraic terms, as you would generally do when you have integers, decimals, and fraction. That's how exactly you have to do here. It's just that they have the x term or the y term over here, but that does not make a difference, but always the like term. That's something that you need to watch out. And I'm sure this is helping you revise it, understand it, watch it again until things are clear to you, and then go and do your independent practice with the video that we have so that you can do better, you understand it better, and you get good at math. Goodbye. See you in the other videos. Bye-bye.